This is a tuning fork. The general idea is that it creates a tone that's at a specific frequency. I can start it vibrating by striking it against something, for example, my knee. Unfortunately, the vibrations of the tuning fork don't transmit directly to my ear very well. I need a way to improve my ability to hear these vibrations. One way to do that is to hold the stem against my head. In this case, the vibration of the tuning fork is transmitted directly to the small bones in my middle ear, which allows me to better hear the tone. I can also hold the tuning fork against what's called a sounding board to improve my ability to hear the vibrations. The tuning fork itself doesn't move much air. I can use this large flat surface to increase the amount of air that's moved. Now I can hear the tone better. In this video, we'll talk about tuning forks in more detail and why they produce the tones that they do, and see how those tones can be changed. Now let's talk in a little more detail about how tuning forks vibrate. This is my picture of an unmoving tuning fork. There are two arms and a stem. I can start it vibrating by hitting one or the other of the arms with something. During one half of the vibration cycle, the tips of the arms will be moving away from one another, as shown here, creating a shape like this. The dashed lines show the original tuning fork shape. The movement of the fork tips also causes the stem of the tuning fork to move up. In the second half of the vibration cycle, the tips of the tuning fork arms move back toward each other, finally ending up in a position like that shown here. The movement of the fork tips causes the stem of the tuning fork to move down. The cycle of the movement of the tips of the arm and the stem repeats itself at the frequency the tuning fork wants to vibrate at. There are two spots on the tuning fork arms that don't move at all. They are called the nodes. The important thing to remember here is that the arm tips move back and forth, the tip of the stem moves up and down, and the nodes don't move at all. Also remember that the vibration frequency will be different if the mass or size of the tuning fork changes. The up and down motion of the stem is what creates the sound when the stem is placed against a sounding board. Now let's do a demo of this and measure the frequency of vibration of a couple of forks. I have an app on my phone here that displays the frequency of a musical note that is played to it. I'm going to tap this fork on my knee and use the table as a sounding board. The frequency it's giving me is about 500 Hertz. This particular fork has some weights that I can attach to it to change the frequency. I would expect that adding more mass will make the frequency lower, but let's check and see what happens. Now I'll wrap the fork on my knee and the frequency is about 150 Hertz. The frequency went down when I added the weights. Things that are heavier, all other things being equal, will tend to vibrate more slowly.